Very good afternoon. My name is Alvaro Lopez, and I'm the marketing specialist for the Latin American office for the U.S. Grains Council. It's a pleasure to greet all of you today and give you this warm welcome. And I'll be accompanying you today as your moderator in this session about the African swine fever, where we will be hearing experts presenting related to vaccines that are being developed and researched, biosecurity, and an update on the swine sector in the Dominican Republic. Since some of us don't know each other, I wanted to highlight that the U.S. Grains Council is a private entity, a nonprofit organization that their mission is to develop export markets for corn, sorghum, and for barley, everything produced in the U.S. And just as co-products or byproducts related to these three cereals or grains, with the interest of providing information, updated, up-to-date information related to the African swine fever, today we have three experts that will share their experiences in each of the different mentioned issues. I take advantage to greet the Dominican Republic and the veterinary division of the Dominican Relations and people that helped us with this webinar in this space, and there's livestock section. And now Pedro Chavez will come in, which will give us some opening remarks. Thank you, Alvaro. On behalf of, I wanted to thank everyone that is here present in this transmission, this talk, which its purpose is to educate, to build awareness about a reality that ever since July or August of last year actually hit our national pork industry and swine industry and contributed. We want to contribute to with helping farmers and helping all the participants of this industry to understand this. A special recognition to the different students from the different universities that are present, ISAUS, Howard, and the different universities that are participating. For us as a private sector, having them here is very important for us as well. I think we have an excellent group of speakers lined up and presenters. So therefore, I invite everyone to participate fully to understand, and Alvaro will explain the different details and how the dynamic it's going to work for this event. Thank you so much. Well, thank you so much, Pedro. And give me a second. Up next, Pedro, thank you, Pedro, and forgive us for that small moment of blooper that I just had, that small minute of silence. But let's continue with today's agenda. We're going to begin our program with Dr. Casey Jones. She's going to present about feed and the virus and biosecurity at the farm level. We're going to continue with pork sector, swine sector with Dr. Ismael Brito, and presenting about the global presence of the virus and new different strains and advances in the development of vaccinations and vaccines. And we'll begin with closing remarks on behalf of engineer Santiago Mora. So I am going, before I present our speakers, I wanted to give you a few housekeeping items about the platform that we're using right now. First of all, your microphones have been disabled and your cameras as well. In order to ask any questions, please look for the Q&A icon on the bottom part of your Zoom screen. And please also use this button to ask questions to the actual speakers, the Q&A button. This option also gives us an opportunity to ask questions anonymously. But in that same menu, you'll also have a chat symbol that you can use for your comments, not necessarily to ask questions for the speakers, but any different questions related to the activity, like any situations that you may have with language issues, etc. So we're going to be sending you a survey at the end of the session as well. So we ask you to participate and fill it out, please. And lastly, we tell you that the event will be recorded and we will make this event available to our participants. So in order to select your language today, one of our speakers is going to be speaking in English, so we have simultaneous interpretation available into Spanish. We ask you that at this particular moment, those of you who have not done so, please go to the bottom right of your Zoom screen and look at the globe that says interpretation and select one of the channels, Spanish or English. If you leave it on off, then you'll hear the speaker in their original language. You can also let us know in the chat, as I told you earlier, if you have any difficulties, technical difficulties in terms of selecting your button, your preferences. Oh, remember, you can change the language to Spanish or English at any moment. I'm going to continue to present our next speaker, Dr. Cassandra Jones. Dr. Jones is an expert in swine nutrition. Her team is from the University of Kansas, Kansas State University, and she's they're recognized as one of the most prolific in feed and risk control and biosecurity. Her research about animal nutrition and safety in food and security assesses the effects of ingredients and different processing technologies for balanced feed or food. Dr. Jones, she's part of the U.S. Feed Task Force, which collaborates between the industry and regulatory bodies like ASB, NFBP, NPPC, AFIA, USDA, FDA, just to name a few. And provides recommendations for prevention of ASF in balanced feed. Dr. Cassandra has represented the U.S. in the academic sector and the AFFS in risk assessment for the USDA sector, where she's participated in FAO under that same capacity. Dr. Jones, ever since 2019, has published more than 10 articles and participated in more than 33 different workshops and conferences. And Dr. Casey is currently an lead investigator for students of Kansas State University in the Animal Science Department. Dr. Jones will be presenting risks in infection and balanced feed and precautionary measures in order to avoid for your farms to be infected. Dr. Jones, it's a pleasure for us to have you accompanying us this afternoon. Please go ahead with your presentation.
Thank you, and it's my pleasure to visit with you this afternoon as well. As I begin sharing my slides, I appreciate the introduction. I'm always a bit humbled by it, but I'm excited to get to work with a different group today. One of the things that I've been asked to talk about is give some updates on biosecurity, and I'll also explain some background for why our team has decided that feed is an appropriate target for us to consider as we think about biosecurity and biosecurity risks. But before we get there, I get to be the first speaker today, and so I'll introduce just a little bit of background on African swine fever. This is really in a context that I like to explain it to my students. I call this virus something that has the good, the bad, and the ugly. And so there can be some good things about ASF compared to other potential viruses. For example, humans cannot contract the disease by consuming pork. And that's one of the most important aspects that I think is important for us as a pork production and as an agriculture industry to continue to press and describe, that humans cannot contract the disease by consuming pork from affected animals. And it's also not a disease that could be transmissible to non-swine species. It's obviously swine fever or swine flu virus. It's not going to be likely to affect other livestock or humans. And likewise, the steps that we take to prevent ASF transmission are also effective at preventing all the other viruses and all the other pathogens that we might be concerned about. So for example, here in the United States, we are fortunate to still be ASF negative. However, we have plenty of swine viruses that we work actively through biosecurity to try to prevent and control. And so the steps that we're taking currently to prevent ASF transmission are going to be just as effective at preventing ASF as they are at preventing our current domestic pathogens that we do have. That's about all the good that I have about ASF though. And so other than that, it gets bad and then it gets ugly. And so the bad thing about African swine fever virus is that we know it can be transmitted from wild boar or ticks to domestic pigs. Many of your speakers later today will talk about how that can pose some unique challenges for eradication of the disease when it comes into a country. And it also has a high case fatality, but it's a delayed case fatality. And so what we've seen in various countries is that unfortunately that leads to a frequent late and misdiagnosis that allows the disease to spread before we can recognize what it is. ASF does not have classic symptoms that you walk into a barn one day and have very obvious symptoms that this must be African swine fever virus. Many of the symptoms of the disease are similar to those that may be symptoms of other viruses that affect pigs. And so as a producer is making decisions about why are my pigs sick? Why do I have a slightly higher mortality? What's going on? And as they're collecting samples, we continue to have movements back and forth from that facility and from that barn. And unfortunately, have shown in various countries that we spread disease during that time between when we first understand or see clinical signs of the disease and before we actually diagnose that as African swine fever virus. And then we have the really ugly stuff. Again, as we have here currently, there is no available or vaccine treatment for us here in the United States. I know that we'll be talking extensively about potential vaccines and vaccines that are in use across the country currently, or across the globe currently, and some of the challenges and actually some of the risk that exists in utilizing some of those vaccines before they're truly ready for commercial distribution in a safe manner. Currently, for example, in the United States, our planned response is a stamping out activity, meaning that we'll humanely euthanize everything within a certain geographic radius of an outbreak, because we do not believe that there is an effective vaccine that we're willing to go with currently. That is looking promising as we look at the future for vaccine development, but as we stand today, there's limited options for vaccine or treatment. African swine fever virus is one that survives, and boy, does it survive. It survives in fomites for extended periods of times, and that's really how it best spreads to new areas. And I always end with the fact that the virus is spreading faster than the speed of research. Unfortunately, this is something that takes a long time for us to research. And as we've identified that this is an issue within our pork industry, within our feed industries, within the agriculture industry, we can't create solutions fast enough. As we work on this area and continue to do research, the speed with which we try to generate solutions is much slower than the speed that the virus is spreading through new countries and within a country. And that poses some really big challenges for us as an industry, because it forces us to make our best guess at controls and use the best science we have available, even though it's not as bulletproof as we would like it to be. And so it's not a comfortable place for us to be, where we would much rather rely on very sound scientific information. Right now, we have to go with what we have because the disease continues to spread. As I think about that, though, I do want to clarify that African swine fever virus does not just magically jump from one country to another. It is, just like any other pathogen, something that requires a very specific pattern of transmission. And so I just like to remind people of that for pathogen transmission to occur, we must first have a reservoir, that habitat where the agent, in this case African swine fever virus, lives, grows, or multiplies. And then we need to have a susceptible host, something that is susceptible to that disease. And in the case of ASF, we know that domesticated pigs, feral pigs, wild boar are all reservoirs and potential hosts. And then we potentially also have wild ticks and non-domesticated swine that play a role there as well. The step of transmission is the part that's particularly unique. And that's really what my focus for today's presentation is going to be, is how do we prevent this transmission from occurring? And transmission most frequently will occur through direct transmission. It's most likely to occur through direct nose-to-nose contact, where you'll have a pig that is affected by a pathogen come into contact directly through the blood, through the salivary secretions of another pig, and that's how this disease is passed from one animal to another. But in some of our countries where we are ASF negative, or in areas where we're isolated from the disease, at that point, we try to protect our indirect methods of transmission. And that one gets quite a bit more concerning because there are a number of things that could be indirect methods of African swine fever virus transmission, because the virus can live in so many of these fomites for such an extended period of time. Here's just a quick example that I wanted to share with you of how African swine fever virus has really spread over on a kind of a global basis through kind of the 2018 to 2020 time period. And I think it shows a really nice progression of how the disease has historically spread across the globe. First, it started with slow nose-to-nose contact with wild boars. And so when we initially see in this kind of Eastern and these European areas that slow nose-to-nose contact, that virus moving about 2 to 5 kilometers a month, that really parallels the movement of wild boars. And we would anticipate that that's likely through direct transmission. But then we have these jumps. And we have this jump where this area of Russia went positive. And then as we continue on with the video, we see that adjacent areas go positive for the disease. And then pretty soon as I continue talking, China, of course, goes positive. And then we have these massive jumps to our Caribbean islands and to our countries in the Western Hemisphere. And so the question being, if we don't have direct nose-to-nose contact with affected wild boar, how does the virus even get there? And in that case, we believe that those would be cases of indirect transmission, where whether it's a pork product that was smuggled into a country, whether that's an affected feed or ingredient that was contaminated and then is transported to that country and is consumed by an affected species or a susceptible animal, we believe that that indirect transmission is potentially how new countries become positive. But then once we have a positive African swine fever virus occurrence within a country, then it can spread pretty widely through both direct and indirect transmission. We've studied this intensively in one of our partner countries in Vietnam. And so one of our values at K-State is that we have a lot of production systems that we are partners with. And one of the largest production systems in Vietnam, early on in their initial outbreak, worked with us extensively, where we've collected well over 8,000 samples in working with that production system. Now, to be fair, this is a relatively modern production system. This is not backyard pork production. This is relatively modern, large-scale pork production. They own their own feed mills, multiple site production, and they have their own finishing as well as their own packing facilities. The goal of this project, though, was to use diagnostic testing capabilities to understand the risk of how African swine fever virus was spreading throughout their production system. Help us understand, as they're in the middle of a country with an ASF outbreak, what things are they doing within their production system that work, what things don't work, and where's their biggest risk for spreading the disease to new barns, new animals within their production system, or to other production systems within the country. What we found is we really isolated our sampling to kind of 3 different categories. The first was the feed production system. In that case, we had 17 positive samples out of about 2,300, and that's the one that I'm going to talk through more. We also looked at their live animal transport and their market animal transfer center. And we were surprised by the latter 2 with how low of African swine fever virus numbers we found in our environmental samples. Again, this is in a production system in a country that we know has African swine fever virus. We know that they were hauling to and from affected sites and potentially were hauling affected animals. But this is a production system that was doing an exceptional job of cleaning and sanitizing the outside of the vehicles and the trailers being used by that live animal transport. And within their transfer center, they were cleaning and sanitizing routinely as well. Whenever we did find positives, they were almost always in the cabs of a truck, not on the outside or where we're actually hauling pigs, but actually where the drivers sit. And that's similar to what we found in the feed production system. Numerically, and also on a percentage basis, we found a greater prevalence of African swine fever virus being transmitted through the feed production system than through either the live animal transport or the market animal transfer center. And so we dug into this one a little bit further. Again, when we look at those 17 samples out of more than 2,000, I first want to emphasize that's not that many positives, right? Again, we're dealing with a production system that's in the middle of an African swine fever virus outbreak. And so only 0.7% of all of those samples were positive for African swine fever virus DNA. This production system was doing an exceptional job. But what I want to point out is where there were gaps, because I think that's really where the rest of us can learn and improve as we continue to implement some of the activities that they've done. Within those 2,300 samples, we were surprised that none of them were from ingredients. 3 were from feed contact, 4 from non-feed contact surfaces in feed mills. 2 were from people in the feed mills, but a lot of them were again from trucks. And so when we look at how we move feed from one country to another, how we move feed from one location to another, it really has become a challenge for us to understand that feed mill biosecurity is part of the entire biosecurity area. And I'll maybe share an example with how this could occur. Historically, we've always thought of ingredients as maybe being the cause for carrying some type of pathogen. And that absolutely could occur. In that case, we could have an ingredient that is maybe from a contaminated facility that makes its way to a feed mill, and ultimately through the feed mill can affect multiple different farms. But we could also see this same effect occur, but through backwards transmission. In this case, it's possible that we will find a pig at a farm that contains or is affected by African swine fever virus, whether that's through indirect or direct contact through some other fomite. But the rest of the feed supply chain is not at fault. But unfortunately, because of the way that all of the feed deliveries are linked in the world, it's likely that as soon as one pig in a farm goes positive, that entire barn is likely going to be considered to be affected. And as we're going through the fact-finding decisions of how did that pig, what disease is this, the 17 to 21 days of incubation period between the point of when that animal was affected and when it shows clinical signs of disease, during that time, we've probably made 7 to 8 different deliveries of feed to that feed mill. And so the feed truck that was delivering to it is likely affected now and potentially has some African swine fever virus containing DNA. When this occurs, there's potential for that to then be transported back to the mill and the feed mill to be contaminated, which then if we have a contaminated feed mill and a contaminated truck, we're likely to spread that to other farms, back to the ingredient facility, and ultimately potentially spread that to other production systems. This is what we believe we've observed through the epidemiology of what we've worked with in Vietnam. More often than not, we are seeing disease spread through the feed supply chain in a backward movement, where feed biosecurity becomes a really important aspect, but it's not because of the ingredients, it's because of the trucks that are moving back and forth. We have excellent farm to farm biosecurity, but we struggle with farm to feed mill to farm biosecurity. And so that's an area that our team has really been actively working with. Here's an example of why this is such an issue. And so here's a recent research project that we just completed where we evaluated African swine fever virus and what effect that can have in feed if we manufacture it using some equipment. And so what we did in this scenario is we took a feed mill and we initially used that feed mill to manufacture ingredients that were free of African swine fever virus. And we, as you would expect, just like how you make feed any other way, is you add ingredients to a mixer, and then you disperse that and discharge it through a bucket elevator, and then you ultimately discharge it typically into a truck or into a bag. In this case, we were dealing with a highly virulent pathogen, and so this is a picture of me in a high containment suit as I'm catching the feed. And then we collected samples of of 10 different samples from that feed to understand which of those samples have African swine fever virus. We initially did that with a batch of feed that did not contain any African swine fever virus. And then on purpose, we added ASF. And we added ASF on purpose to the mixer, again, conveyed it through a bucket elevator, discharged it into a separate tote and collected samples. And then we followed that up with another negative batch of feed and four subsequent batches so that we could see what happens if you just get one single batch where you have some contamination in the feed mill, either in the ingredients or gets mixed into your mixer somehow, and how does that potentially affect the prevalence and the distribution of African swine fever virus in the feed that you're maybe going to be delivering to 1 or 2 or 20 different sites later on. Here's the data from that study. As I look at this, this is initially a table where we were detecting the quantity and the number of African swine fever virus containing samples of those feed. And again, we collected 10 different feed samples. So that first batch of feed had all ASF negative ingredients. None of them contained ASF. And as you would expect, that means of this 10 samples we collected, fortunately, none contained African swine fever virus. Next, we have the batch of feed that we on purpose added ASF. And in that case, as soon as we added ASF into the mixer, every single one of those samples was ASF positive. Viruses are a lot like vitamins or medications or other ingredients. We can mix them into feed really well and distribute them throughout a batch of feed very evenly. But of course, our main interest was what happens after this, how many of those subsequent batches of feed might actually have residue of African swine fever virus. And in the case of the 3rd, 4th, 5th, and finally 6th batch, every single sample we took had either suspicious or confirmed levels of African swine fever virus, demonstrating that as soon as this virus gets into our feed manufacturing system, it stays there. And it's very sticky in terms of a virus that tends to be distributed into every batch of feed that you manufacture after that initial positive sample was manufactured. And of course, the other concerning thing about African swine fever virus is that it's so stable. We took that feed and sampled it beginning at day 0 all the way for 6 months later. And every time that we collected a sample of that feed, its virus concentration level, the quantity of DNA that we found in that feed sample was very, very stable for out to 6 months. The other piece that is important for us to understand from a biosecurity perspective is that not only did we look at the feed, but we also looked at the manufacturing environment. And so in this case, again, we had our mixer where we had our mixer and our conveyor and then our discharge. And any place that those ingredients touched, we called those zone A. Then we looked at what happens on the outside of the manufacturing equipment, but still in the feed mill. And so anything that was located within 1 meter of the manufacturing equipment, so this would be like the floors and the walls and the exterior of the manufacturing equipment, that was called zone B. And then anything more than 1 meter away was called zone C. Now, like most facilities, we also have some transient zones, things like people or trucks that move in and out and move as between one zone to another. And so we had air and the shoes of researchers that were our zone D, because they occurred and moved between zones C and B and C as they moved between those different zones. So what we did next was we looked at and analyzed environmental samples from what was collected in each of those different zones. And along the y-axis here, I have the prevalence of African swine fever virus on these different surfaces over time as we manufactured that product. And initially, as you look at the feed contact surfaces, it's not surprising to find, after we saw that feed-related data, that we found feed samples all the way through sequence 4 that were ASF positive. Well, that's because when you look at the environmental sample, the inside of that conveyor, I can still pull about half of those samples, half of the locations of the inside of that feed manufacturing system still has ASF containing DNA. Alternatively, when we look at surfaces outside the feed manufacturing system, but are either nearby or further away, we still show that African swine fever virus is present within the feed mill. And this is really concerning because once someone or something steps on or moves or gets contaminated by that product, it goes positive and stays positive. And so one of our biggest concerns are things like the shoes of people who work in feed mills in contaminated countries, because these areas continue to show the highest level of contamination for the longest period of time. And so as you think about maybe a worker making feed in a feed mill that maybe gets contaminated, and then they go and deliver feed in the bottom of their shoes, walk around a farm and go up on top of a feed bin, that's really a potential way how we could spread African swine fever virus into a new production system. So what should we do? There are three main things that we really recommend people focus on. The first is to exclude high-risk ingredients altogether. At this point in time, it's really imperative, it's necessary to know your supplier of every ingredient. And if you're importing or utilizing grains from an African swine fever virus country, make sure you know what region those are from. We require high biosecurity during the manufacturing process, during storage, and during transportation, and we exclude those high-risk ingredients altogether. For example, many places in the United States no longer will allow specific ingredients from countries that are known for having African swine fever virus because of that concern. Or if they do have to utilize them, they make sure that they follow one of these other potential mechanisms that I'll talk about in a minute. And that's this one. We try to take advantage of opportunities to reduce the survival of infectious virus in those contaminated ingredients. And so when we need to utilize, because of either economics or just availability, when we need to utilize ingredients from ASF endemic regions, we encourage people to utilize holding time because viruses die out over time. African swine fever virus, as we showed, is very, very stable, but it's more stable in things like soy than what it is in other items like vitamins or amino acids. And so there are some ingredients that we can hold for a period of time and quarantine them before their use. We've also demonstrated that thermal processing and chemical additives, such as formaldehyde-based ingredients, where they're approved for use, as well as medium-chain fatty acids, are things that can be added to feeds or ingredients to prevent the virus that they may contain from causing infection within an animal. And finally, to wrap up, we can prevent the potential for farm to mill to farm contamination. We've really studied a lot of the concepts of on-farm biosecurity. It's important for us, for example, to manage the shoes of workers. And so here's a great example of something we have at our farm at K-State. We call this a Danish bench system, where employees come in, open the door, they sit down on the bench, take their shoes off on this side, and then they swing their socked feet over onto this side of the bench and then go on and do their chores. This is an example of something that's very common in farms in the United States, but it's not ever seen in feed mills. As we start to understand the role of farm to farm disease transmission, as well as farm to feed mill to farm transmission, things like this have become much more popular and much more common for us here in the States. And so even when we're looking at things like within a feed mill, we have our receiving bay, the inside of the feed mill, and we may have benches like these set up so that we can better understand and limit traffic patterns for what is on the bottom of individual shoes. There's also ways that we can track this. There are products that are called, the one we like to use is called Glow Germ. And that is a dry powder that you can sprinkle down, and you can see it fluoresces under UV light. And so we'll sprinkle that powder on one side of the bench, and we'll watch over time as that powder accumulates and hope that we don't have it appear on the other side. Things like GlowGerm are a really useful training tool for us to utilize in feed mills or with producers as we help them understand where they may be seeing potential risk. We use it as an example that you can visually see for potential fomite-based transmission of disease. To wrap up with then just a little bit of summary of kind of things that we see on a global basis in terms of feed biosecurity. Again, we're starting to see more and more kind of dry foot baths, people utilizing covers and utilizing the sanitation of the exterior of feed and ingredient trucks, making sure that trucks back up to or are loading, unloading into a covered stream. And we see a lot more thermal processing of the entire complete feed at the site of production than what we've ever seen before. Our current projects include understanding the impact of either showering or using these benches or foot baths to prevent the entry of contaminants on farms. We're looking at how do we better decontaminate the inside of feed truck cabs. And we're looking at a number of things that help us quantify the risk of different ingredients as we look at potential transmission of those ingredients from one country to another. So to summarize, my updates for today on biosecurity is really focused on the feed supply chain. The feed supply chain, we do not believe is the most likely route of viral entry into animals. That would be direct transmission. We know direct transmission is much more likely to occur, but that's also something that you can typically control with proper fencing and other biosecurity activities. Unfortunately, the feed supply chain is often a gap that is left open, and we've demonstrated that it can quickly spread disease if we do not address that gap. We all play a role in preventing pathogen entry and spread, and so we always encourage our producers, our feed manufacturers to do their part. That includes excluding high-risk ingredients, consider some type of active mitigation to further minimize the risk of disease, survival and infectivity, like the use of chemical additives or thermal processing of that feed, and then implementing feed mill biosecurity. The same things that you see being effective on farms, it's important to also be implementing those on feed mills. And finally, we just ask that you continue to help us understand the problem and potential solutions. The data and information we've received from Vietnam has been fantastic to help us better understand and provide solutions to people as new countries go positive. And so as you or our countries continue to experience challenges with African swine fever virus, continue to share what works and what doesn't work so that we can all learn from one another to address these issues. And with that, I will turn over and just leave up here that I have our website that has all of our citations, all of our literature and scientific copies for free, as well as my email address, which is jonesc@ksu.edu.
Dr. Jones, thank you so much for that presentation, really. It was very instructive. And well, definitely we can conclude that biosecurity and the implementation of biosecurity with our swine is key. It's set up. We're going to begin with some questions that we keep getting from the platform for Dr. Jones. So, Dr. Jones, the first question is, how many meters away should you put the bathroom for the disinfection of the personnel? How far away should it be from a project, the bathroom?
Oh, that's a great question. As far as possible, but at least more than 3. And so one of the things that we've recognized is that as we manufacture feed, and again, I'm also thinking about this as we look at patterns of dust distribution around a farm or facility, we routinely find virus from contaminated facilities or equipment within 1 to 2 meters of where the pigs are located or where the virus was introduced in the feed mill. And so we would like to have at least a 3-meter kind of quarantine space or isolation space to allow for the dust to be limited in terms of how it can be blown from one area to another. Now, if there's wind, that's not going to help. And if there's rodents or birds, those are all things that make this more complicated and more challenging. But when we look at just the initial volume of virus that can be expelled during an African swine fever virus or other virus outbreak, typically 3 meters at least is what we look for an isolation space.
Perfecto.
Perfect.
Muchas gracias.
Thank you so much.
Bueno, esta es una
Well,
pregunta que entró en
this
inglés.
question was asked in English, but I'm going to try to translate it into Spanish.
Y dice,
And it says,
tipo
what type
químicos
of
usted
chemical additives would you recommend as a treatment?
cuál parte del
And in what part of the process?
Yeah.
Would-
So this is one that we've done a lot of work with, not enough. We still need to do, as an industry, we need to have more solutions in this area because we don't like the solutions that we have right now. In the United States, we have approval to utilize a product that contains formaldehyde, and that product is very well known as a sanitizer of feed. Unfortunately, it has some not so great effects on the environment and on the employees who might be utilizing it. And so because of that, it's tightly regulated here in the United States, and it's not approved for use in livestock feed or animal food uses in many countries. But we know it works, and it can destroy or basically render African swine fever virus in feed to be non-infectious. Alternatively, there are other acids that we can typically use. African swine fever virus is pretty widely adapted, but if you acidify the feed enough, then once you move away to an acidified feed or a highly alkalinized feed, you can also address the infectivity of that product. The product that we utilize the most would be medium chain fatty acids. And they would have some unique characteristics that when added at 0.5% of the diet, sometimes that's not very cost effective, but when we add 0.5% of medium chain fatty acids in the fatty acid form, not the triglyceride form, we've demonstrated that that prevents African swine fever virus from being infectious.
Perfect. Thank you so much.
voy a continuar con
Up next, we'll continue with
presentando al doctor Israel Brito.
the presentation of Dr. Israel Brito. And Dr. Israel Brito, he is from Guantanamo Santo Domingo University. He graduated in 1980. Dr. Brito was the professor of the Catholic University and he's currently a swine producer, and he's beginning he began pork production in 1983. Israel has been the general manager of Cofenol for more than 20 years. He's the president of the Federation of Swine Producers and the president of the Administrative Council from the co-op, the Agriculture Co-op of the North. Israel, the presence of ASF in the Dominican Republic has been a painful test and of resilience for the swine sector, and we're really happy to have him here. Thank you for your participation in this event today. Thank you again, and please go ahead. I said in the beginning, I was saying that I wanted to thank all the different organizers and the sponsors of this event. Great event, really, which for us, the Dominican people, it's going to be very useful for all of us at this particular moment where we have so much uncertainty all of us are, all of the pork farmers in
La
the
porcicultura
Dominican
dominicana,
Republic. Well,
perdón, República Dominicana
the Dominican
comparte con
Republic
Haití,
shares its border with
el
Haiti.
territorio de la
It shares
isla
the
Hispaniola,
territory of the
de la
Hispaniola
cual
Island.
nosotros
And we
utilizamos, las
are
2/3 partes.
2/3 part of
Con una
Hispaniola
población
Island.
aproximada
Our
de
population
11
is approximately
millones,
11 million
de habitantes y un
inhabitants
consumo per
and
cápita
a per capita
de
consumption
aproximadamente 15
of approximately
kilos de
15
carne de
kilos
cerdo
of pork
por año.
meat per year.
Previo a la llegada del virus,
Before
de
the
la
virus
fiebre
ever
porcina,
arrived, before the
República
ASF virus
Dominicana
arrived, the
producía
Dominican
el
Republic
73%
had 73%
el
of
resto
consumption. The
correspondía
rest
a
corresponded
carne de
to
cerdo importada,
imported meat,
principalmente de
imported
Estados Unidos de
pork
América.
meat from the USA.
Nuestro consumo
Well, our consumption
estaba sustentado
was
en
actually
algo más de
based
100,000
on
celdas
over
madres que teníamos, de las
100,000
cuales el
female pigs,
35%
and 75%
correspondía a
of
cerdos de
those
traspatio
were,
y el restante 65
and from the
estaba
sense
alojado en
75,
granjas
and they were
de
actually
más de 20 celdas
within
madres hasta llegar a
many
2,800
farms until
celdas,
it
que
reached
es la empresa
1,800 female
porcícola más
pigs,
grande
which is one of the
de nuestro
largest
país.
industries, pork
Al
industries in our countries.
momento de llegar la PPA,
Well, when PPA or when
nuestra
ASF arrived,
porcicultura
our
estaba distribuida en
swine
más
farming,
de
our pork
20,000
farming was distributed
productores,
in more than 20,000
generando
producers,
más de 60,000 empleos
and it
directos
generated more
e
than
indirectos,
60,000
razón por la cual para
employees,
nosotros esto no es
jobs.
solo un problema sanitario,
So this is not only
sino
a
que también
hygiene issue for
representa
us,
un
but it also
problema social
represents a social and
y un
economic
problema
problem,
económico.
represents
Social por la gran
social
cantidad de
issues because of
personas
the great
que se ven
amount of
involucradas en
people that
ello,
are
miles
involved
y
in this
miles de
industry.
productores que
Thousands and
dependen
thousands of
directamente de
farmers
ello, como
depend
dije anteriormente,
on this,
el 35%
and
de
35%
cerdos de traspatio,
of
que son
these
personas que
pork
tienen
and these
esos cerdos
sows
como,
that have
posiblemente como única
the
fuente de
that
ingreso.
pork is their only income. These,
Desde el primer trimestre
ever
del
since the
año
first quarter
2021,
of
se
2021,
venían reportando muertes de cerdos. las
we've
siguientes.
seen deaths
Se
of
venían
pork,
reportando muertes de
and
cerdos,
we've seen a lot
principalmente
of
en los
deaths,
productores de
mainly
traspatio.
in these types of small mom and pop farms,
Fundamentalmente en la parte oeste de nuestro
fundamentally
país,
in the western
donde
part of our
hacemos
country,
frontera con Haití,
where we
y
have the
también
border with
tenemos,
Haiti, and we also have
facilidades portuarias de donde
different
llegan
port
barcos,
facilities
a
where
donde
we
llegan
see ships
barcos
come
de
in
distintas
from different
partes del
countries
mundo.
and different parts of the world.
Con Haití, nosotros
But
tenemos
with
una
Haiti,
frontera
we have a
bastante
border,
porosa
a
de
very porous
362
border,
kilómetros.
362 kilometers of
A
almost
esos
all
cerdos,
open border.
se le estaban tomando muestras
And we were taking samples from
para
these
ser
pigs in
llevado
order
al
to
laboratorio y
take them to the
analizarlo
labs
contra la
and to
peste
analyze
porcina
them
clásica,
for
enfermedad
classic
esta que
ASF,
es endémica
which is
en
an
nuestro
endemic
país,
disease
porque
in
la
our country,
tenemos desde el
because
año
we've had it since
1998 y
1998,
todavía
and
no hemos
still
sido
we've
lo
not been
máximo
able
posible
to eradicate
autodeclararnos
or
libres de la
self-declare
misma
ourselves
enfermedad.
free of the disease.
Esas muestras
Those samples
resultaban
resulted
negativas
with negative,
y
they had negative
se
results,
fueron acumulando en el
and we started to
laboratorio
accumulate them
hasta
in the
que
lab
a principios
until
de
at the
julio
beginning of July,
volvió a reportarse
we
una gran
start to
mortalidad
see new
en
reports of
la
mortality
parte oeste también
in the western
de
part of the
República
country, of the
Dominicana, la
Dominican
siguiente.
Republic.
En la parte oeste de
In the
República
west of the
Dominicana,
country
en
of the
una
Dominican
granja
Republic,
de
in one of
70
the
celdas
farms,
madres.
it was
Esa
with
mortalidad,
70 sows.
principalmente en
That
los
mortality in the
animales
70 sows and these
dio una voz de
older
alarma.
animals
Y se
actually triggered
presentó
an
el
alarm.
equipo técnico
And
de
the
la Dirección
technical
General de
team
Ganadería,
and the general cattle farming
conjuntamente con
division
un
and
médico
swine
veterinario que
and
nosotros
livestock division
enviamos, que los
with a
acompañaba,
veterinarian
para
that
poder
we sent to
determinar
accompany
a
them.
ciencia cierta
They
qué
tried to
estaba
determine
pasando
exactly
con los
what was
cerdos
going on
que se
with the
estaban
swine,
muriendo
that were the
prácticamente
pigs that were
todos
dying
en esa zona del país.
in that area of the country.
Eso ocurrió
Well,
el
that
día
occurred
16
on
o
the
17 de
16th or
julio del
17th
año
of
pasado.
July of last year.
Desde ese mismo
Ever
momento,
since that same moment,
aún sin tener los resultados del laboratorio.
without having lab
Las
results yet.
informaciones que teníamos
The information
era
that we
que se
had were
trataba de
that
una
this was
enfermedad roja.
related to
Desde el
uh,
principio, quien habla
very
descartó
deadly
el
disease, and
problema
nobody
de
discarded
la peste porcina clásica
swine
porque
classical
dichos cerdos
ASF because
estaban vacunados.
these pigs
Se
were
procedió
already vaccinated.
en ese momento
At that particular
a
moment,
recolectar las
they
muestras
proceeded to take
y
further
conjuntamente
sampling
con las demás
and
que
jointly
tenía
with the other
el
samples
laboratorio,
that the lab already had,
se enviaron al laboratorio
they were
de
sent
Plus Island
to
en
the
Nueva York,
Plus Island lab in New York,
donde se diagnosticó
where
la enfermedad,
we had the
llegando los
diagnosis of
resultados
the
a
disease,
finales de julio.
and the results arrived at the end of June.
De esas 368
Out of those
muestras que
368
se
samples that were sent
resultaron
to New
positivas
York, we had
muestras
positive
de 13
samples
provincias
of
de las
from
32
13 different provinces
que
out of the
tiene
32
República
provinces or states that the Dominican Republic has.
Tan pronto como se dio la voz de
As
de
soon
alarma del
as the
diagnóstico
alarm
de
was
fiebre
triggered
porcina
after
en
the
nuestro
African
territorio,
swine fever
los
was
organismos de
re-diagnosed in our
sanidad
territory,
animal
our health,
internacionales
animal health authorities at a
acudieron a
national and
República
international
Dominicana
level came to the
para
Dominican
colaborar
Republic
con
to
nuestras autoridades
cooperate with our authorities
la implementación
in the
de técnicas
implementation
del laboratorio
of
que
laboratory
permitieran el
techniques that will
diagnóstico
allow us
rápido
to have
de la
quick
enfermedad.
diagnosis of the
Justamente
disease or the virus.
así ha
Precisely,
ocurrido y
this
como
what
ya
has
estábamos haciendo
happened,
las muestras
and
aquí,
since we were already
el
taking
diagnóstico es
samples
aquí
and
y
doing our own
se
diagnosis
estaba
here,
procesando mucho
and
más
since we were
muestras,
processing and taking
apareció la
samples,
enfermedad
the
diseminada
disease just popped up
en
and it became
25
disseminated in
provincias.
25 different provinces.
Posteriormente,
Later on,
eso fue subiendo hasta
that
llegar hoy día
started
a
to
30
rise, and now it has touched
y
30 of our
donde
provinces
se
or
ha
states.
diagnosticado hasta la fecha más de
And up to the
1,100
moment,
focos.
we've already had
Aparte
about
de los animales que
1,100
en
focal
principio
points
se
already
murieron
diagnosed,
sin
apart
saber
from the
realmente
animals that died
cuáles eran
earlier
las
on
causas
without knowing exactly
que
what the true
le habían
cause was
llevado a la muerte.
that might have been ASF.
Es importante
Well, it's important
resaltar,
to
es
highlight,
importante resaltar
it's important to highlight
que
that
por la sintomatología y
due
los
to the
resultados del
symptoms
laboratorio,
and due to our laboratory
virus
tests,
que hoy
the virus,
tenemos en Dominicana,
which we have
es
in
un
the
virus
Dominican
con baja
Republic today,
patogenicidad.
is a low
No así
pathogen
de poca morbilidad.
virus.
Un virus que se mueve con la
It's a
misma
virus that moves
característica
around
que
with
se
the same
mueve el virus de la
characteristics
fiebre porcina
like the
africana.
normal African swine
Eso lo
fever virus moves,
manifiestan los
and that is
síntomas que
manifested by the
presentan los
symptoms
animales
that our
y
animals are
cuando la
presenting,
enfermedad se ha-
and when the
donde la
disease
enfermedad se ha
or where the
presentado,
disease has been
puede
presented,
presentar con síntomas variables.
we can see
Puede
varied
darse
symptoms,
caso de que haya
like
vómito,
cases where there's
que
vomit,
haya abortos,
where
que
there's
haya
spontaneous
inapetencia, y en
abortions,
algunos casos
and different
no hay
issues. And in
fiebre.
certain cases, there's not even fever.
En algunos casos
In
no
certain
hay fiebre.
cases, we don't even
Hasta
see
ahora,
fever. Up to
el
the
virus que
moment,
se ha
the virus
identificado aquí,
that
la
was
cepa que se ha
identified, or
identificado
the
aquí,
placenta that
es la
has
cepa
been
Georgia
identified,
2007. A
is
pesar
the Georgia
de que
207
extraoficialmente
strain, even
se sabe
despite
que
artificially knowing that
existen otras
there
cepas
exist
ya
other
en
strains
nuestro territorio.
in our territory already.
Hasta la fecha,
To date,
hasta la fecha, se han
up till
sacrificado
now, we've
más de
sacrificed
142,000 cerdos.
over
Y el
142,000
gobierno ha tenido
pigs, and the government
ha
has had
tenido que
to
erogar más de 20 millones de dólares
spend more than
para
$20 million
compensar a los
for
productores que se
compensation
le
to
han
farmers
sacrificado,
that had to
sus
sacrifice
cerdos.
their
En
production.
principio, se estaban
In the beginning,
sacrificando el foco,
they were
se
sacrificing the
estaban
focal points, and they were
sacrificando el
sacrificing
perifoco.
the
En un
perifocal
radio
points
de 3
with a perimeter, a 3-kilometer perimeter.
Un par de
But
meses después,
a
esa
few months
práctica
later,
se
that
abolió
practice
y
was
solamente,
abolished,
seguimos
and we
hasta
only
ahora
continue now
sacrificando los
sacrificing the
Es
focal
lógico
points only.
entender
It's logical
que
to
República
understand that the
Dominicana
Dominican
es un
Republic
país con
is a
limitaciones
country
económicas, que
with
venimos
economic
de salir
limitations,
de la
that we
pandemia de COVID, donde
just came
todos los
out of the
gobiernos del
COVID
mundo
pandemic,
tuvieron que
where all the
invertir
governments in the world had to invest
grandes sumas de
huge
dinero.
amounts of
En el
money
caso nuestro,
on
se nos
COVID issues.
presenta
In our
también
case,
la
we
fiebre
also
porcina
had
africana,
African
y el
swine
gobierno
fever
ha
hit us
tenido
at the
que
same
hacer
time, and the
fuertes
government has had
erogaciones
to
para
actually
compensar agricultores
take trade-offs to
afectados,
compensate
cosa que
the
nosotros,
producers and the
agradecemos.
farmers, and we really thank them for that.
Esta enfermedad no
Well,
discrimina,
this disease does not discriminate.
así como se presenta básicamente en los
Basically,
cerdos de
It
traspatio,
happens in
también ha
backyard
afectado
pigs, but it's
varias
also
granjas
affected
con
several
población
farms
de
and
300
populations of more
cerdas
than
o más.
300
Inclusive, en
sows or more,
principio, una granja de 1,200
and even a farm with
cerdas de ciclo
1,200
completo, donde hubo
sows
que
of
eliminar
complete cycles,
toda la población.
and where you have to eliminate or sacrifice
Posteriormente,
all of the
se
population.
presentó
Basically,
en otra granja
it
de
happened in
2,000,
another farm with
200 y algo de cerdas,
2,200
y
sows,
ha afectado también
and it's
uno de
also
los centros
affected
genéticos
one of the
que
genetic
teníamos
centers
en
that we
República
had
Dominicana.
in the Dominican Republic.
Para finalizar, es importante
In order to end,
resaltar lo
it's
siguiente.
important to highlight the
Hoy
following.
día,
Today,
hoy día seguimos haciendo
or
lo
nowadays,
mismo
we continue to do the same
estábamos
thing
haciendo
that we were
hace 8
doing
meses,
8 months
eliminando
ago,
los focos.
sacrificing the focal
Cada vez
points,
más se
eliminated
complica
focal
por la
points,
gran
but it becomes more and more complicated due to
del
the
virus,
great
al medio
presence of the
ambiente y la
virus in the
facilidad
environment
de transmitirse
and the
que
capacity
tiene el
of
virus.
transmitting or spreading
Está
that this virus has.
formándose
It is,
un equipo
we're
para
creating a
la
team
erradicación de la
to help
enfermedad en
eradicate
nuestro
the
territorio,
disease or the
pero
virus in our
todavía
territory,
hasta la
but
fecha
to
oficialmente
date,
no ha sido
officially,
presentado,
that
se
team
está
has
en la
not been
contratación
presented
de los
or the
técnicos,
hiring of the
se
technicians has
está
not been made yet. They're working
conjuntamente con la
jointly
colaboración
with
de
the collaboration
EFI, que
of
tienen sus
EFI,
técnicos en
that they
República
have
Dominicana,
technicians from the
y
Dominican
formando un
Republic,
equipo
and
de
we're
EFI y un
creating an
equipo de
EFI
República
team
Dominicana
and the
para
Dominican
la
Republic
erradicación de la enfermedad.
to help
Lo
eradicate
cierto
the
es
disease. The truth
que
is
esta enfermedad
that this
mantiene
disease
una
continues
incertidumbre total a todos
to
los
keep
porcicultores dominicanos,
all
a los
pork
que no le han llegado la
producers
enfermedad,
in uncertainty.
porque
Those that
no se
haven't been
sabe
hit by the
en
disease
qué
yet
momento
are
va
scared
a
because they don't know
aparecer
at
el
what
virus,
moment the
no
virus will
importando
appear
las
in our
medidas de
farms,
bioseguridad, porque todos tenemos que
notwithstanding
entender que no
biosecurity
existe
measures, because
riesgo
we all
cero en
we all need
bioseguridad.
to understand that there's
Y
no
más
such thing
aún
as zero
a los
risk in
productores
biosecurity,
que
and
se le han
especially
eliminado
for
sus cerdos
farmers
que
that have
todavía
had their
no tienen fecha
production
de
sacrificed that don't have
cuándo
a date
repoblar, a
related to
pesar
when they
de
can
que hay
repopulate their
productores
farms,
que va a
despite
hacer ya 8
having
meses que se
producers
le
that
eliminó sus cerdos.
sacrificed
La
their
enfermedad sigue en pie,
production more than 8 months ago.
siguen
The disease
apareciendo
continues.
focos.
And we
Como
still
les
continue
dije
to see focus
anteriormente,
points or
van más
focal
de
points appear.
1,100
As I told you
focos
earlier, we have more than
diagnosticados ya
1,100 diagnosed
oficialmente,
focal points
y
officially
eso para
diagnosed.
nosotros
And for
realmente
us,
constituye
that
una gran
truly
amenaza
constitutes a
para un
big
sector
threat
tan
for a
importante
very
de la
important
economía
sector
dominicana
of the
como es
Dominican
nuestra
Republic
porcicultura.
economy, which is our
Muchísimas
swine
gracias.
sector. Thank you very much.
Álvaro, micrófono.
Don Israel, muchísimas gracias
Dr.
por
Israel, thank you so much for
programa.
giving us that scope.
Por ese,
And thank you
el reto que tiene la industria.
for letting us know about the challenges in the industry from this point forward. And that information is welcome. I
Actualmente conectados.
probably assume that many of you that are connected understand this cycle, and understanding how it works is very important for all of us. So continuing with our last speaker,
Es el doctor José Manuel
Dr. Jose Manuel Vizcaíno. Dr. Sanchez Vizcaíno
España.
was born in Murcia in Spain,
Yo y doctoró
and he has he
Complutense,
was from the Competencia de Madrid veterinary
los grados de inmunología y
this is, and he's studied virology in Cornell University, New York. In 1978, he went back to Spain and he joined himself as a researcher in the agriculture and feed investigation center in EMEA. And during this period, he became the researcher and the director of several different departments as the lead director of biology and animal hygiene, and the director and founder of the Center of High Biological Safety and Security, BLS3 plus,
investigación de sanidad animal.
in terms of human animal security. As a professor, he's contributed with the control and the eradication in 4 different continents. Amongst those, we have the African swine fever, the horse fever, and the classic fever. Dr. Sanchez Vizcaino in 2021 was named an emeritus professor of animal hygiene, and he has more than 50 scientific publications at an international level. He has directed more than 150 projects for research projects, 37 PhD theses, 80 research contracts, research and development projects, 10 patents, and he's participated in more than 500 summits or conferences and courses and interviews. And they've named him 14 times. They've decorated him 14 times. His scientific interest is focused on the study of technology and preventative measures from infectious animal diseases, developing new techniques for diagnosis and latest generation vaccines. He's currently the IP of several investigation projects, amongst those that are highlighted after the Bactiva, the call for proposal HB 22, the ASF 2019 call for proposals, and vaccination for African swine fever. Dr. Vizcaino will give us a global perspective about African swine fever, the risks that this represents to the world, and this doctor will be going into depth about advances in the vaccine and the challenge with the different strains of ASF that are currently flooding the world. Dr. Vizcaino, it's a pleasure to have you here. Thank you so much for participating in this event, and the floor is yours.
Thank you, Alvaro. It's a pleasure for me. From the bottom of my heart, it's such a pleasure to be with you all. I have great love towards you all, especially seeing what's going on and what Israel just represented. So I want to show my solidarity towards you all. And you know, I'm here for whatever you need and whenever you need me. I'm going to talk about my friend, and I say friend because I've been working with him for many years. And the virus of African swine flu started in '68, but I had never seen a situation as bad as this one. Such a complex situation and difficult one. So I'll leave my email here in case any of you want to ask me questions after the Q&A, or in case you have any additional comments that I might be able to help you with. As you know, this disease, even though it was described in 1921, i.e. it's a disease that should be well known, continues to be relatively unknown for most colleagues, or for the majority of colleagues. And as well as being unknown, it's also underestimated to a high level. And this is due to the fact that it's been in relatively few places, despite leaving Africa 3 times. This is the second time that it visits you over there. And as you know, it has left 3 times. And this is the last time in 2007. And it has led to a situation that we've never seen before, where it's affecting all 5 continents. There are still people, I must acknowledge, that do not understand it too well, including its transmission mechanisms and resistance. That's why it's so complex, as well as the way that it enters countries. So for the first time in history, it has reached 5 continents, affecting more than 50 countries at the moment. The worst situation, just to summarize, because I don't have too much time, but I'd like to tell you the most important aspects, without a doubt, is currently in Asia. In Asia, incredible things have happened over the last few years, and a while ago, this was reported by our colleagues from China mostly, because that's where the situation is worst. And this is where they've started to find a number of attenuated strands and great circulation of the virus through contaminated food or feed. Illegal vaccines are a reality seen in China for a long time now for genotype 1 and 2, so very low strains, attenuated strains, and low virus strains, And as we said before, they're illegal vaccinations that are sometimes marked with the name of a prestigious center, so Harbin Institute, and they've told us many times that they have nothing to do with this, and we of course believe them. They also say that they buy them as contraband from Spain and Vietnam because they know that these are two places where we are working with this vaccine quite a lot, but they can also be sold via the internet, so that is truly impressive. The thing that worries me the most is the large number of ships that leave China where they have loaded feed for their trips and for people managing the boats. And when I say boats or ships, I mean those that transport trade, so containers that have increased their entry through various continents quite a lot. That includes the American continent, North and South, and obviously Europe and Africa, etc. So why is the situation concerning to me? Because the African routes for transmission are very significant and they're relatively unknown. People still do not understand the secrets of this virus. This evening, I'm going to try to explain many of those secrets to see if I can somehow help you in that fight and that struggle that you will continue to experience. First of all, the thing that we find most commonly in the world is infection through feed produced using infected pork meat, fresh food, semi-cured food that maintain the virus for a long time. So I'll tell you why this virus structure becomes a sort of fort that has two resistant barriers both in cytoplasm and in the nucleus. So this feed is able to keep the virus for a long time, as I will be showing you, and the fundamental entry to new countries is mainly through this contaminated feed that comes either via air transport or via vessels, mostly through vessels that carry containers or merchandise. Then the virus is tremendously resistant, as I'll be showing you, therefore in trucks, on the soles of people's boots that touch the virus, it really stays there for a long time. So it may be contaminating surfaces for long periods of time, and you'll see that just a drop of blood contains more than 3 million copies of this virus. That means it's enormous. The virus is often found in blood and also in stool samples, and obviously in everything that touches blood or stool, as I said before, which could be, for example, a truck with contaminated animals. If it's not adequately disinfected, it will contain the virus for a long time. Also, people wearing shoes or boots that go through a contaminated area will maintain that infection there for a long time. And as well as being transmitted through these routes, there's also direct transmission in which two animals that are infected are both domestic pigs and also wild boar. They really disseminate the virus, and we also have different mites, this vector, and these aren't just mechanical vectors. They obviously spread by stinging animals, or biting animals. The thing I'd like to say here is that it's very transmissible via aerosol, and also this is more infection than others, PRSS and others, but there's a very high level of infection transmitted orally. We're going to tell you about some of the secrets that you need to be most careful with. So the main word here is blood. As I said, the virus is found in large quantities in blood. And in fact, this image that you see here is an erythrocyte in a red blood cell, where you can see this little particle at the top, and you can see how the virus sticks to it, meaning that it will have a large quantity in blood. So you have to be very careful when you are sacrificing animals or performing necropsies, or if you're hunting. You mustn't forget that bugs or flies, they love blood and they love stool, and they can easily take that virus to faraway places. So it's really important to remember that blood and feed are the two most important mechanisms. And look at the level of resistance, the ability to resist. At 4 degrees, it can be more than 110 days, under 20 degrees, more than 1,000, and then 4 degrees in blood, it could be for 18 months there in a farm that hasn't been adequately disinfected. It can be there for a month. The month can be there stable for a month, the virus. So imagine how resistant it is.
Fundamentalmente en este momento. La vía
How does the
principal
virus arrive mainly? The route for entry to various countries is mainly through imports or places of risk, or normally it goes in through food that has been used in routes to reach these countries that has been bought in infected countries. So this feed basically comes in through 2 routes, either because it's being used to feed animals in kind of backyards. So those of you who have a high level of these, maybe even 70 something percent, 33% of those could be in these areas. So this is one of the entry points that is very common. So they go in through the backyard and at the industrial level through people who buy medication or who visit others. So there are lots of mechanisms here that are fundamentally through human vehicles or through contaminated trucks, for example. So this is one route. The other route that we often see as well is when the feed is taken to picnic areas or to resting areas where you have a lot of wild boar, and what they do is they eat the food in rubbish cans or bins, and they eat it and then they transmit it to domestic pigs, because wherever there's wild boar near a farm, they will enter the farm. So these are the most normal routes that we see. So entry through feed and also amplification, either because you've given that to them in the backyard or because they're in wild areas used for picnics, etc. How can we protect at the public and private level? When I say public, I mean, what does the state need to do? And when I say private, what does a farm need to do to avoid it? We still do not have a vaccine, even though it's closer than ever. I'm going to talk about that later, but we don't have a specific treatment, and therefore we have 2 tools that are key here. The first is early detection. Early detection is vital. Early detection is, for example, as Israel was telling us a while ago, what failed in principle in the Dominican Republic. They really took a long time to understand that it could be African swine fever. Biosecurity is the other tool. Therefore, we have 2 vital aspects that I'm going to tell you how we can improve them. First of all, we need to train cattle farmers and so that they can, and vets as well, so that they can be suspicious of it and send samples to the lab. And in second place, biosecurity measures so that this virus does not enter the area. So these are both very important. They can be done at the level of the farm or the vet, and they're the things that we can work on the most. Then there's a quick response that's more at the state level. There should be a good contingency plan in this case, and also enormous collaboration between the public and private sectors.
de entrada, generalmente, una vez que la enfermedad
What are the
ya
general entry routes once the disease has reached a country? Mainly through feed. So how does it enter farms? So through feed, contaminated feed going into these farms, or whether you have wild and domestic areas where infected animals that are both domestic or wild can go to these farms. Also, any workers that have been in other farms and that are wearing the same shoes, because sometimes you think that after a while or after a minimal distance, the virus will die, but actually it's very resistant over a long period of time. So please listen carefully. Nobody on the farm, none of the personnel should consume food at the farm that has been produced with pork or this kind of material, because it can enter the farm through their sandwich. So these are cases that we've seen before. Vehicles are another mechanism that is seen very frequently, so a lack of cleanliness, a lack of protection, and they simply don't think about all these elements that can carry the disease, such as flies that come into contact with the blood in the stool in many of the areas of focus, precisely due to the blood and the shoes and the food. There's always an original point of focus, but generally there are many due to the dissemination through blood or through flies themselves, due to a failure in biosecurity. We also have rodents and reinfection after a kind of specific outbreak. People are quick to disinfect, but they do it very quickly, very badly, and fill their farms again. And there's another outbreak due to the high resistance of the virus, and we should above all avoid sending infected animals to be slaughtered. Otherwise, in countries where you already have the disease, the ability for it to recirculate through contaminated food will be never-ending and with high probability of it becoming endemic. Biosecurity is without a doubt the main measure and measure for prevention that we have, and the best safety mechanism for biosecurity. But there are two types of farmers, as we all know: those who increase biosecurity because you have to follow the law, and those who believe in it. In this illness, or this disease, if you do not believe in biosecurity, then don't be a farmer, because you will surely have the virus. And here we see the two extremes. On one hand, we have these kind of backyards and family farms that we see in many, many countries, where they feed pork, where they feed pig with kind of leftovers or rubbish or that kind of thing. And in my experience, having eradicated this disease in many countries and many continents, is that when you do not provide compensation for the farmer, it's very hard for that country to eliminate the disease, because farmers will, or when they've just had an infection, the first thing they'll try to do is slaughter the animals and sell them to butchers wherever they can. So that's clear, and there's a lot of illegal sale as well. As for those with the greatest levels of security or safety, they do not receive compensation either. This means that the risk increases, the risk of them not declaring it quick enough. And above all, what we see the most is reinfection after an outbreak, because they haven't adequately cleaned and they repopulate the farm in an accelerated manner. So how can we at the state level, I mean, there are things that we can do as vets and farmers, but there are other measures where we need the support of the public administration. We need a good surveillance program, for example. This isn't a static or stationary mechanism. It should continuously change depending on the scenario where we are working, and also depending on the risks in each area. And even in one country where you may have different risks, different levels of surveillance.
Generalmente, como os digo, no se hace. El otro
And
problema,
how is this generally done?
ahora mismo circulando, como os decía, en China están llegando cepas
So
de
as I
alta
was saying, there are
o de virulencia
strains that are have higher kind of charges or levels of the virus
pero que son bastante
that
sintomáticas, bastante
are
que nos pueden
very
dar idea de
symptomatic,
que puede ser
and they can indicate whether it's African or not. But we can also have strains with lower levels of the virus, and what we'll see is a completely different case. So we'll see kind of the inflammation of joints, see issues with their feet, and this has nothing to do with more acute versions. So at present, food is contaminated coming out of China of both these types of strains, so we need to pay close attention to that and to these kinds of symptoms. What are the points of risk? Generally, given the epidemiological circumstances, as I said before, we would have to perform supervision of. Without a doubt, private airports, don't worry too much about international airports, because they have a rather sophisticated waste treatment system. Many countries take the rubbish with them that they brought on trip, and they take it back to their countries. Either pay for it to be disinfected or incinerated generally. but private airports or airports for merchandise, especially those that have boats with or vessels with containers in border areas, they honestly don't work very well. So be careful with feed or food, be careful with waste, be careful with food waste, and above all, be really careful in countries that receive humanitarian aid. There are certain countries that are providing good humanitarian aid to other countries that have been affected, but at the same time, there are countries that are free of the disease and they need humanitarian aid, and unfortunately the food that they receive is sometimes infected, so we need to be careful with that. And there are many other countries that have been affected around the world in this way, as you know. And also the type of farm is very important because it's not the same risk. Let's say the risk of in an industrial farm compared to a backyard farm is different to that a family may have, or those who look for food for their animals in rubbish. And this really changes the way that we should supervise and the way that we should perform surveillance. We mustn't forget that these animals also have certain ticks that exist in some countries and not others. And so if those ticks are there, they may help the spread, and also be careful with wild animals like wild boar, where that's also spread very easily. And there's a lot of illegal movement as well. When there are certain countries with low compensation, low biosecurity, when they tell me there's an outbreak there, I already calculate that there's probably another 6 or 10 outbreaks. And if we don't have information about the movement of that initial outbreak, then we will be completely lost. But we mustn't forget what I said before. And in second place, the repercussions of this isn't just on the country where the disease is, which is obviously very high, as I mentioned before, and we saw in the data provided by Israel, which I thought was very interesting. But above all, neighboring countries or countries with strong relations can also end up being infected, because let's look at the following. So if somebody's eating salami or some kind of food like this in these wonderful holiday places in your country, and you like that kind of food, how would that person know that if that was taken back to their country, someone could die? I mean, they don't understand that this can happen, because even though a virus may not affect humans, it can affect the swine in that country. So I've noticed there's a generalized high level of misinformation among people, some who do it due to business, and others who honestly don't mean badly, but do create significant risk for this disease. So you might notice the summary that I have here, just to have an idea of where the problem actually lies. The fundamental issue is early detection. You can see that that mainly falls upon the farmer or the cattle farmer. Normally they don't have much training or have very little information, and they can't distinguish between different diseases. And when they take a few days, or once they know, they'll try to sell the food, sell the product as quick as possible. Many of them don't have private vets either. So most of these backyard farms do not have vets.
Tienen veterinario privado. Con lo
Or
cual,
even medium-sized farms don't have vets either. So they honestly don't really know what's starting to happen or appear. All they know is that they're dying and they will sell them. So generally, private vets, for example, do have the training to detect this disease, although sometimes the symptoms aren't as clear as you'd see in the books, so you don't detect them. So what they do is they call official vets. So the delay that there can be between the private vet and calling the official vet, who will implement measures and take samples and take them to the laboratory, can be quite lengthy. The lab is an important slab of or part of the chain, but the laboratory cannot perform miracles because it simply diagnoses that which arrives at the lab. But if it doesn't arrive at the lab, then it can't do anything. The big failure or issue with early detection is up here in this part. If laboratories have been well trained, they can even say how long the infection has been there, which means that you can calculate where it has come from, where it may have gone, and much more. But these are the two largest, most important parts, and especially this one here. As for the parameters that we should assess, we have created a kind of self-analysis, i.e. we have detected these 9 points so that the farmers, cattle farmers themselves, can self-assess their biosecurity levels. So we've divided this into different parts. So where the exploitation has been located, whether it's close to other farms,
incluyen traspatio o ciudades
whether
pequeñas.
they have backyards or whether there are small cities or populations behind them, whether the construction of the site is of good quality, whether it has clean material, whether it can be disinfected, or whether it's kind of dirty, also where there is presence of wild animals like ticks and wild boars, whether there are kind of these fences separating the entrance from the parking area so that the trucks don't come in, and also whether entry and exit movements are being recorded. This is super important. It would be great for every farm to have a book where it records entry and exit. Thanks to these books and thanks to the information that many farms have, when we arrive at a place that has had an outbreak, we can see where the virus has come from, because the lab will tell us whether it's been there for a while circulating, and we know that if there is a high level of antibodies, so the places they have gone to, because that helps prevent secondary outbreaks. But if we do not have this information, it's very difficult to be able to understand where the secondary outbreak may be. And then also forcing people to change their shoes and wash their hands, and also their clothes. At least changing your shoes and washing your hands should be compulsory. The shoes that people bring in should not go into the facilities. There should be an external area where they can change their shoes and wash their hands. And then the absence of domestic animals that shouldn't be present at a farm, they just make things tricky. Also having areas where let's say there are graves of small animals. Obviously small animals will die in these areas. What are we going to do with the corpses, or maybe slurries as well? What are we going to do to avoid the amount of blood that's being produced in these areas? This is absolutely fundamental. And then obviously we have anti kind of fly material and things that help us to keep birds outside as well, like windows. So as for the vaccination, let me tell you how this is going. This has been a dream that many of us have had for many, many years, since 1921, in fact, when in Africa, specifically in Kenya, they detected the fever, and in the 60s, the first vaccination was created. It was an experimental vaccination in a field in Portugal and Spain. What they found in these particular cases is that attenuated vaccines are the best protection that we have today. I'll show you another set of vaccines that do not work, the activated ones. The only ones that work are the attenuated vaccines. But what are the issues with these types of vaccines? So if they haven't been stabilized, what they do is revert the virus, i.e. That's very frequent in attenuated vaccines that are not stable. And this reversion of the virus can create virus or virus residue, means that the symptoms reduce, as is the case in Asia, as we showed you in the pictures. And what this does is generate carrying animals that are then slaughtered, and that affects the country because they create food with these products and they carry more attenuated strains. So why is it so difficult to have a vaccination for this particular marvelous virus? Well, because it's a very complex virus. So I created a kind of X-ray here just so you understand the complexity of this virus in comparison to others that we have in animal health, and specifically for swine, which are very, very different. So the African virus has 160 genes. So comparing it to the PRRSV, where that only has 10, a parvo or PCV2 that has 5, you will probably imagine, or even COVID that has 10 genes, just so you get an idea. We have created a vaccine for pets in just 10 months against COVID, but in Africa, there are many genes that we still don't understand their function. It's a very complex virus. It's a DNA virus, as you know, double chain. As you know, it has 170 genes.
Compleja que todavía no conocemos del todo. Fijaros que estamos ya a punto de sacar vacunas importantes y todavía no conocemos mucho de la complejidad de él. Hemos avanzado mucho en conocer genes ligados a la virulencia, que esto nos ha permitido hacer atenuaciones más seguras, pero genes ligados a la activación inmunitaria no lo conocemos muy bien. Tenemos además un virus que tiene una doble barrera, le separa perfectamente una barrera en el citoplasma, pero es que en el núcleo tiene otra, con lo cual, aunque rompiera la del citoplasma, el núcleo le mantenía con capacidad infectiva. Como digo, es el más resistente que hay. Además de eso, tiene una enorme variabilidad genética, es decir, que el virus no es solo un tipo, sino que hay muchos virus, hay muchas variantes de ese virus. Y además, por si fuera poco, no produce anticuerpos neutralizantes, es decir, no tenemos un anticuerpo como en otros virus, como en el 99% de los virus, que induce un anticuerpo que bloquea al virus para que no infecte. En el caso de africana, no
In
tenemos.
the case of the African swine fever, we don't have that type of antibody. So we have to look for immunity that is not neutralizing. But apart from that, we wanted to sterilize so it doesn't maintain the virus. And we don't have a capacity in vitro of studying the cross protection of our vaccine for how many variations of this virus it is efficacious and for how many it's not. As you can see, it is a complicated virus. And as you can see, it's costed us quite a bit to be close to a vaccine as we're doing right now. As I told you, inactivated vaccines don't have a protective response. The vaccines that are created with proteins or structural proteins from the virus
Strains
that
of
are
the
not
virus which aren't enough to create immunity. TNA ones don't generate or generate weak immune response that does not protect, and the only ones that have high indexes are the attenuated vaccines. But remember that they have a difficult point of balance between efficacy and security, meaning that the fact that now we have more knowledge thanks to molecular biology that are very important in this century. There are two models, and I'd like you to know about this, and I think they work quite well. They have a few differences, but they have a very similar strategy. So the research being performed by Manuel Borca in Green Island that we are carrying out in Europe. So these are the two groups that are closer to getting a vaccine. They're doing excellent work as well. In the European Union, the European issued a call so that we would create a vaccine in 2018, and we created a vaccine with 3 characteristics that I'm going to tell you about later. These vaccine models that we created were for a number of candidates, not just for domestic pigs, but also for wild boar. As I said, we started in October 2019 with a budget of 10 million euros. This is the highest amount of money that the European Union had provided for project. We created a consortium because we needed collaborators in different places and partners in a number of countries, 13 countries, 3 outside of the EU that had infections. So Russia, Kenya and China, which I have the honor of coordinating. So we're going to move on to the next one. The objective of this vaccine has been to produce a safe vaccine. So this is the order: secure, DIVA meaning that you can differentiate between infected animals and vaccinated animals, and an effective vaccine that will help for domestic pig and also for wild boar. So we're working on 3 prototypes. As I said before, we have selected the prototypes that are working both for swine but also for wild boar. I'm going to talk a little bit about those later. And then that vaccine should also have a diagnosis method in parallel for the DIVA system. And finally, we incorporated another target that I consider is of utmost importance, and that is providing not just a vaccine, but also a vaccination tool. So what we do is epidemiologically study a lot of different epidemiological scenarios where there are infections of this African swine fever, where there can be infections in the future, to direct a vaccination program with a specific strategy for that vaccination to be as effective as possible. This is the Vactiva project. We are performing trials live in wild boar. We're doing that at the university, at my university, here in Madrid, Spain, and the domestic ones are being treated in Perugia in Italy, in a very interesting European lab that has been cooperating with African swine fever for a while. The other laboratory is Spanish. It's my previous home. It's the center that I founded in 1992, which is the CISA. It's also here in Spain, and it's a laboratory, a high security laboratory, much like ours. The protection that we have for domestic pigs at the moment is 100%, and the protection for wild boar is also 100%. In the case of domestic pig, it's through injection. In the case of wild boar, that is through some kind of bait that we put the vaccine on. We've studied the ones that they like the most in dry countries, in wet countries, in hot countries, etc. We finally found the bait, the specific feed that we use for animals to become immune. The big issue we have in Europe is wild boar. And by that, I mean the European Union. Eastern Europe has issues with both. They have a lot of domestic pig issues, but in the EU, they mainly have wild boar issues. As I said, there's 100% protection with no side effects. We have a DIVA test that's already operating, meaning that we can differentiate between our vaccine from other viruses or from those who are not vaccinated, and we've created some mutations as well to improve the DIVA and the safety of the vaccination, meaning that today our vaccine is an attenuated vaccine with the elimination of concrete genes that I'll be showing you later, that not only allows us to have a powerful DIVA but zero virus as well. This is how the DIVA will be working in our vaccine. We have created a gene per marker, and here we have the animals that have been infected, and we have and those who have been infected, as you can see, I'm going to summarize this here. Those who've been infected will produce PCR, because obviously this is a DIVA that can be detected due to the production of antibodies, but also the variant gene. In the case that it's an infected animal, it wouldn't be positive in the marker. Those that are vaccinated would be positive for the marker that we incorporated, but not one of the genes that we've eliminated, so B, but it would have A, and those that are negative will be negative to all three. So as I said before, this works for PCRs. So if we have a DIVA that can be molecular, for example.
As I said, we're in the final phases of the studies of our vaccination at a domestic pig level and at the wild boar level as well. And we've seen some pictures. Here's some pictures of how we work. These are wild boars. You see, it's more complicated to work with them. We actually buy them from local producers that keep them to repopulate hunting zones. But we buy them when they're super healthy, when they're free from disease, and we bring them to the faculty. This is an animal from the faculty, and this is the pictures of the first ones that we vaccinated, the first that we discovered that the vaccine can work in. And if you see here, I put them next to a control that you can notice here how this one is much worse here. In fact, this one was very sick, and these were like a rose. And this is a vision of how we continue, or we follow up on everything, because we control all the settings 24 hours a day. We control the whole environment using this system that actually works quite well here. So you can see as well how we actually go through studies, and if the vaccines in the wild boar and domestic pigs, how it can be transmitted into wildlife or backwards. Since we can't put them together, we have a system where we've proven that there's close to 2,500 kisses snout to snout between them. There's a lot of sympathy amongst wild boar and the pigs, and we're allowed to see if there's transmission or not, but they actually like each other. So the vaccine, as we said, is oral for wild boars and injectable in domestic pig. And we're preparing the pilot program studies that we're going to do with the wild boar as well as with domestic pigs. We're assessing several different places, locations, maybe in Asia. We're going to do a trial run, our pilot program, the first one that we're going to do in Asia, and also in Kenya with these two wild animals, which are the ones that continue the virus to propagate in Africa. And we're going to do it in this famous ILRI Nairobi Institute. Well, this is the summary of everything or how the vaccination is going at this particular moment. The studies of in vitro and living, we already have them done. It's partially done. The mutant ones are still on. The adaptations of prototypes with cellular lines. We already have mutations that are adapted to cellular lines. And our mutant, this one that we're going to select, is already adapted to that line. Over vaccination, well, what we've done, what happens with a wild boar that takes it takes 25 instead of 1, or what happens if at domestic values you double vaccinate or triple vaccinate because you forgot or you got distracted or the veterinarian doesn't know. So we have this in animals. Now we're actually doing this with mutants, and immunity time. We're continuing to experiment because these are long experiments, and immunization and domestic pigs with a great deal of animals. We're in the process right now of doing this with larger samplings. And as I said, we're going to repeat this in many different samples. Well, we have the Diva adaptation, which was partially already done, and we're actually finishing this with the mutants as well. And then the conservation of the other ones, and we're working with the colder countries, and then cross protection as well. How many strains from the different strains that are circulating, how many of these strains can the vaccination immunize and help resist those strains? Right now, the mutant is actually working the most. And in terms of the future, what is going to happen in the future? How do I see African swine fever? Well, as I said, the future of ASF will continue to advance. We've been working on this for many years now, where some countries are not capable of controlling ASF because many things go wrong that I told you about earlier. But I'm open to your comments and questions. I fear that it will continue to advance. In certain countries, it's going to become endemic for many years, unfortunately, for several reasons, really. And if you want, we can speak about those reasons as well. But the vaccination is closer than ever of being developed. In fact, Vietnam already developed or declared they already have a vaccine. And well, this one uses technology from our colleagues from Plume, but I can't guarantee it. Yes, but the Vietnamese say that it's working wonderfully. But ours, as I said, is progressing quite rapidly. And well, I wanted to really thank everyone for this invitation. As you know, for me, this is a pleasure to share with you any moments, because I've always been to your country and your country in general, and your Latin American countries in general. Your countries are beautiful, and I wanted to thank the Complutense University of Madrid that helps finance this and another part of our investigation. And I wanted to help the OIE of Animal Health for the International OIE organization. As you know, we're the worldwide center for reference for this. And obviously to the European Union and to the VACDIVA project that is allowing us to get a lot of work done. And thank you to this team here that you see here. This team has been, or this team, two have been from your country, and we went to help in the diagnostic phase. Here you have Sandra, and here you have, these were, they came to our country as well. Both of them, Stephanie and Sandra, went. And the rest of the team, my team from Africana, this is only for the Africana team. And as you can see, it's a mostly women team, and at your disposition, I'm here open to any comments or questions. Thank you so much to everyone once again, and a big hug from here. Thank you from all my heart. Well, Dr. Vizcaíno, thank you so much. A very complete presentation. Well, at this particular moment, we've actually gone overboard a little bit out of time, so we're going to skip our break. And let's go directly into Q&A. I'm going to try to give each conference a time to try to answer at least 2 questions. And then probably, depending on how quick we answer, we'll continue with Engineer Santiago Mota to close the event. Well, let's begin with our first speaker, Dr. Jones. Dr. Jones. Well, one of the questions is, how do you take the samples for PCR samples, and with what velocity do you get how quick do you get the results from the PCR test?
Yeah, that's a great question. Depending upon the type of sample we're collecting, if it's an environmental sample, we typically take it using cotton gauze and then place that gauze into phosphate buffered saline and incubate that overnight and extract it the following morning. And typically we'll have results as long as we have access to a diagnostic laboratory, which in Vietnam, the production facilities that we work with, they have their own diagnostic capabilities there. And so we typically get those results within 24 hours of sampling. In terms of feed, that one's actually more complicated because feeds and ingredients can have other things that can interfere with the extraction of DNA. Even though ASF is very stable, sometimes some of those feeds have cations or other forms and components in them. And so typically we need to centrifuge those and allow them to sit overnight and then centrifuge them down, pull off the extract, the supernatant, and we analyze that supernatant. But again, typically within 24 hours. And so as long as we have access to a diagnostic laboratory, usually we can get PCR results within 24 hours.
Perfecto, muchas gracias, doctora.
Perfect. Thank you so much, Dr. Jones. Now, the second question. What is the minimum frequency for cleaning that you for trucks and the bazookas? Bazookas are food transportation trucks. That's what they call them, bazookas in the Dominican Republic.
In that case, it depends on how many sites within your production system are maybe affected. What we routinely do with our production system in Vietnam is that we have trucks that are considered dirty, meaning that they only go to ASF positive locations. And those trucks are cleaned and sanitized every night, the inside and exterior of them. And then the exterior is cleaned and sanitized every time before it comes into the feed mill. We have other trucks that are only feeding ASF negative sites and production systems. And those trucks are cleaned and sanitized before they enter the feed mill and at every use. And so that could be up to 10 times each day.
Perfecto, doctora
Perfect.
Jones.
Dr. Jones, thank you so much. And possibly, if we can continue at this rhythm, we'll come back to you with more questions if we have time for it, because there are many more. But let's talk with Dr. Rafael Brito right now. It's a pleasure to have you here. Thank you for your presentation. A very quick question. Are there any studies that determine or will showcase the economic impact in the short term and in the long term of this disease? Well,
nuestra porcicultura
in our
está
pork
valorada
production or our swine farming,
aproximadamente
approximately
500
it
millones de dólares.
was valued about $500 million.
Hoy día, nosotros
today,
entendemos que
we
se ha
understand
eliminado prácticamente
that
30%
we've seen a
de
decrease in
nuestra
30% of our
Si miramos el
swine
impacto
farming.
económico de ese
If we look at
valor
the economic
a-
impact of this
a un
value
largo plazo,
in the long term,
porque
if we
a los
look at this,
porcicultores que se le han
because
eliminado
the
sus
pork
cerdos no
farmers
tienen
that
posibilidades por
have
ahora de
their
volver atrás.
pork
Eso
sacrifice, they don't have
realmente
the possibility to
representa
refarm. That
mucho
really
dinero, no
represents a lot
solo
of money,
para
not only
el
for
porcicultor, sino
the
también
farmer,
para
but
nuestro
also
país.
for our country as a whole.
Muchas gracias, don Israel.
Thank you so much, Dr. Israel.
Ahora continuamos
Now let's continue
con esta siguiente
with this
pregunta.
next question.
Bien interesante.
Very interesting question, Dr. Israel, for you.
Doctor Israel,
For Dr. Israel, what are the methods for sacrificing pork at the farm, and what do you do with the cadavers?
Sí, se ha estado sacrificando
Well,
en la granja a través del
Sacrifice
choque
at the farm
eléctrico.
level
Los
using
cadáveres
electrical
se han
shock
estado
method
entejando.
and electrocution, yes.
Previo un tratamiento con
Obviously,
carbida
we treat
y en la gran
previously
mayoría de los casos.
in the majority of cases beforehand.
listo. Muchas gracias, don Israel.
Well, thank you very much, Dr. Israel. Now for Dr. Jose Manuel Vizcaíno.
Doctor Vizcaíno,
Dr. Vizcaíno,
que República Dominicana
given the fact that the Dominican Republic compensated the farmers, do you think this national policy has reduced the transmission rates at a national level and in the short term and in the long term? Well, definitely. So I believe that this compensation is an extraordinary tool because there are many farmers that are not going to want to hide their pigs because they know they're going to be compensated. I think that's a great strategy, the one you've incorporated, and I congratulate you for that. I sincerely think it's a great tool.
Perfecto, gracias, doctor. Y continuamos
Thank you,
con la
doctor.
del vecino
And
país.
we continue with our neighboring country for you as well, doctor.
Sigue recibiendo ayudas
Haiti continues to receive humanitarian aid.
entró el virus por
Well, did the virus actually enter through this humanitarian? There's a huge probability that this is what's the case. There's a lot of probability, really, because as you know, this is a virus that was in Eastern Europe. It's very probable, yes. And well, I believe that this also has to open up our eyes and to lead us to think that at this particular moment, we have a lot of material, a lot of infected material circulating, and that we have to try to find a way to actually go to the backyards with certainty to the people that actually need them, or facilitate maybe warmers, because realize that this virus, if we just gave them maybe a pot so they can actually heat it up at a temperature that is not too excessive, we would reduce those risks substantially. If I know is that it's very difficult to remove a way of doing things, but there are tools that we can actually implement or provide to decrease this problem. And if we can't suspend the tradition of certain backyard farmers for feeding these types of horses, at least we convince them that they should pass this waste of food through heat. Maybe that virus will die in that sense. This is a system which is very cheap and cost effective. We can implement backyard, maybe pots and pans for people to heat their foods before that, the feed. And Alvaro, let me I heard my colleague, Dr. Jones, and I wanted to tell you guys, and obviously I want to tell her specifically, that for environmental samples, we've described, and it's already been published if you want to see this, but I can give you all the different details that you want. A little certain sponges and that are passed through the environment and that have two advantages. One, that the sponge is very quick, that you mix it with certain mixes of blends of alcohol that is patented as well. And that's maintained as long as you want in the transportation. And for PCR purposes, it has the advantage that when you put it into alcohol, it's no longer infectious. The sample is no longer infectious and you don't have to extract it any longer. So simply directly from there, you take it out and you can run the PCR test. It's a technique that we've thought about quite a lot for countries where environmental factors are easier to work with than bleeding from the animal. So we can do a safe and quick diagnosis, and you don't have to send the sample with large biosecurity layers, because at the moment where you put the sponge in this type of alcohol, the virus becomes inactivated, but the DNA does not get dissolved. So the PCR continues to work properly. Simply, it was just that. And I think maybe it can be very useful for all the environmental studies that you do that are linked to with balanced feed and for grains. Forgive me, Alvaro, if I took a few additional minutes more than I should, but I thought that maybe it would be interesting. No, perfect. Thank you so much, doctor. Well, we have many more questions really that I'm going to summarize them in one, and I'm going to ask all of you. Well, the questions is, would you recommend the complete eradication in the Dominican Republic with Haiti as well? With our neighbors, which already reported more than 6 cases in the territory, would it be worthwhile to do a total eradication or partial one when we talk about the whole Hispaniola Island, Dominican Republic, and Haiti? Who wants to begin? This is a question. What if you want, whoever, you can begin. Please go ahead. Well, I believe that in our specific issue, given the border that you have, which is so open, and the conditions which are so difficult to work with that Haiti has, well, I think it would be impossible to think about total eradication. So I think if you eradicate completely in the Dominican Republic, you're going to have reinfections because of Haiti. I think we have to be way more ambitious. We have to have the whole island has to participate, despite the circumstances that we have that are so complicated in Haiti. If there's a lot of international money, we can actually do this. But if you try to do it only in your country, well, the reinfection capacity that you're going to have is going to be so high that it's not going to compensate things. I think it's way too difficult at this particular moment. And I say this with all my heart. I think it's way too difficult to think about a strategy that you can isolate yourself from the Haitian part of your island. It's impossible with the types of borders that you have which is of so easy access of moving around and how difficult it will be to avoid the infection of one side to reach the other. Well, at least that's my opinion. Well, thank you so much. Israel, I'm not sure if you have something to add. Well, since we took a little bit extra time, I would like to maybe say goodbye to Dr. Jones because she has another commitment that she needs to attend to. So we'll continue if you guys agree with a few additional questions.
Perfecto.
Well, perfect.
Vamos
Not
a hacerlo
a
así.
problem. Let's do it. Let's do it.
Dale, ¿tú quieres añadir algo?
Okay. Do you want to add anything to what
No,
Dr. Vizcaíno says?
realmente esa es la
Well,
verdad.
Really, that's
La
the truth.
frontera extremadamente permeable que nosotros
The border
tenemos con
is
Haití
very open,
y
the one that
la
we have with Haiti,
presencia
and the
del
presence of
hasta
the
ahora
virus.
diagnosticado
Up to this
unos
moment,
cuantos casos.
we've diagnosed several
Y
cases already on the
para
Haitian side,
nosotros eso
and
no
for
deja de
us,
ser un
that
gran problema
is
de,
a huge
para
problem
volvernos a
in order
reinfectar.
to
Debemos de
have
pensar que eso pasó lo mismo
reinfection
con la
possibilities.
peste
The
porcina
same thing
clásica en el
happened
año
with the classic
1998,
ASF virus in
que éramos
1998,
libres
and
y
we
nos
were
llegó desde
actually
Haití
free, and it came
y
from Haiti,
todavía la
and
tenemos en
we were free
nuestro
of the
territorio.
virus, and it came from Haiti,
Esta
and it
enfermedad,
continues
la
in our
situación es
territory.
totalmente
And with this
distinta
disease, the
porque los
situation is completely
controles
different because the controls
no están
are not
tan fácil como es el caso de la
as
peste
easy,
porcina clásica que
like in the
podemos hacerlo combatir.
classic
Desde el principio,
ASF virus.
nosotros hemos entendido
From the very
que
beginning,
debe
we
de ser
understood
un trabajo conjunto,
that this has to be a joint
tanto de
effort
República Dominicana
with the Dominican
como de
Republic
Haití.
and
Ahora, la forma
Haiti.
de llegarle a Haití
In
ya
order,
ese es
the way
otro
to
problema por los
work with
grandes
Haiti is
problemas
another problem
socioeconómicos
because of the
que
huge
tiene
socioeconomic
esa
problems
nación,
that
donde
they have in that
posiblemente
nation, where
el
possibly
problema de la fiebre
the
porcina
problem of the
para
African
ellos
swine
no
fever for
sea
them
el
is not
mayor problema,
the biggest
dada la
problem,
circunstancia
given the circumstances,
económica y
the
sociales que
economic and
ellos
social
están viviendo.
circumstances that they're
Por lo
going through.
que los organismos
So
internacionales,
international
nosotros entendemos que
organisms,
deben de ser
we
los que
understand
tomen la
that
delantera
they're the ones that have
en,
to
en nuestros vecinos
actually take the
para
lead
poder
with our
declarar la
swine in order
isla
to declare
libre
the
de la
island
fiebre
free
porcina.
of ASF.
Perfecto. Muchas gracias.
Perfect. Thank you so much, Dr. Israel. A very interesting question that just came in. Can the virus be spread via river water? And what would be the percentage of spreading if the answer is positive?
Doctor, sí, adelante, por favor.
Nosotros hemos estudiado varios casos en los que
We studied several cases.
los resultados que hemos obtenido. Por ejemplo, estuvimos mucho tiempo trabajando.
So, for example, we worked on trying to find out how the virus entered South Korea and how it was able to enter the country despite the very tight barriers and borders that they have with North Korea. And we see in the areas where they have sacrifices of animals or where we have dead animals being thrown in the river, the virus maintains itself. Obviously, it's diluted a little bit, but we've detected transmission in certain sections of Asia that indicate that water can be a conducting factor. Well, how are they concentrated? Basically, if animals maybe drink, even if there's a small load, it's still probable for them to get infected. We're doing studies in these countries right now to try to understand exactly how much so we can measure it. But the epidemiological data right now do indicate that probably water does play a role.
Buenísimo. Gracias, doctor.
Wonderful.
Esto sí va para ambos y
And this one is for both of you as well, and it's $1 million question.
en un futuro próximo, la
In the near future, do you see
República Dominicana.
the vaccine reaching the Dominican Republic?
Primero Israel.
Israel
No,
can answer that
primero
question
usted,
first.
doctor.
No, you first, doctor.
Bueno, Israel.
Well, Israel, with pleasure. Well, what we believe is that there is going to be a vaccine, Alvaro. And I say this frankly, for me, I'm very happy to tell you that, yes, I'm convinced that we're very close to having a vaccine. I can't guarantee that it's going to be a universal vaccine that will actually stop all the different strains, but it will be able to reduce a large number of the strains. And therefore, I believe that the vaccine will be a reality soon. When is that vaccine going to come into play? Well, in our case, we have to finish testing. I think in the case of Plume, it's a bit more ahead because they've gone through different strategies. But In our particular case, I believe in by 2024, and very possibly we will have a vaccine. If everything continues as is going, we will be able to send vials to NSD company, the one that works with us, that's the NSD company that's within our consortium, so that NSD can produce it at an industrial level. And after all the testing, effectivity and safety data, etc. But I can't ensure that it'll be in 2024. Giving you a specific date is very difficult. But the truth is, what I do tell you with all our heart, and I've been with this virus so many times, is that never, ever, ever have we been closer.
Don Israel, ¿algún comentario?
Dr. Israel, any comments?
No, el doctor Vizcaíno
No,
es
Dr.
el
Vizcaíno,
maestro de la
he's
vacuna. Nosotros la
he's the
estamos
expert in
esperando.
vaccination.
Ojalá
We're
tener la
actually just here
oportunidad
waiting. Hopefully we
de
can
que
have
nuestra
have it soon,
porcicultura todavía
so
en
that
Costa
our
Rica pueda
swine
estar en
farmers
lucha.
can actually implement it.
Bueno,
Perfect.
ya estamos llegando al final.
Well,
Tenemos
I
varias
think we're at the
preguntas que
end,
quedar sin responder.
uh,
Tiempo es valioso.
but time is valuable and it's very important for all of us. That's why I wanted to thank all the different participants, to all those that supported me in helping me organize this event. And now, as we saw on the agenda, let's continue with Dr. Santiago Mota, General Manager from Pecuaria Industries in the Dominican Republic, to close this event for the Dominican Republic. Engineer Mota, please go ahead. Good afternoon to everyone. Thank you, Alvaro, for allowing me to close. I wanted to thank everyone that continued to be connected all the way to the end, almost when we're almost finished. On behalf of the organizing team, composed by Sanut, Instituciones Precarias, and the U.S. Grains Council, I'm going to simply ask you to have a little bit of patience and give me an initial 2 minutes to share certain reflections and conclusions from this very important event that we've had today. We just finished a very enriching day, and it begins with a very important conference that was given to us by Dr. Jones, Casey Jones, speaking about the work that has been done in terms of biosecurity. And from that presentation, we can perhaps highlight what importance exists in maintaining and establishing biosecurity controls in order to guarantee some in any fashion or other that farms are not affected by this type of disease that puts the existence of the farm itself at risk. When we were hearing that presentation from Dr. Jones, I believe that all of us that have had the huge opportunity to hear her, we will be a bit more aware of the importance of biosecurity as an issue and as a theme. And when is it only applicable to the cases that we are dealing with today related to ASF, which is also applicable to the activities that involve the raising of different animals or species. A second presentation that was given to us by Dr. Israel Brito, the president of the Federation of Pork Producers, which he gave us a walk around or a narration of the history and the behavior of the disease ever since it entered our territory in the first quarter of last year. And in terms of certain other aspects that about the presentation of Dr. Vito, and all of us are really dealing with similar challenges and different problems. They may be similar or equal to the problems like when the disease first came into our territory. And as the doctor already mentioned, there persists the appearance of cases, even in the current times and in different points of the Dominican geography, which indicates that the disease continues its course. Well, perhaps from that presentation from Dr. Vito, we also wanted to talk about how important it is for authorities and farmers and producers need to continue to work together with the purpose of mitigation of the harmful effects of this disease, but especially the economic and devastating effects that that generates in the different producers, which has its farm is affected by these types of situations. We were able to have a final presentation from Dr. Jose Manuel Sanchez Vizcaino, which spoke to us about his experiences and gave us many recommendations about how we should establish controls. And in the last part of his presentation, showcased the work that has been done in order to develop a vaccine that can counterattack the disease. I dare to deal with the life of Dr. Jose Manuel Sanchez, and I found that at any given moment, they gave an interview to a reporter from the El País newspaper or the country newspaper, and in that article they declared ASF as his #1 public enemy, and that his life's mission would be or should be the total eradication or the development of a vaccine that would counterattack this disease. And today I want to tell you, Dr. Vizcaino, that your research and your investigation can bear that fruit and provide that gift to the world and to the hundreds of farmers and pig farmers that are everywhere in the world and the planet. That's why I dare to say that, especially in the last part of your presentation, you brought us a talk and you gave us a word of hope. And I can say that you gave current and future pork farmers in the Dominican Republic, swine farmers, you've given us hope. I wanted to thank you for dedicating your time and thank you for dedicating your knowledge to such a noble task. And hopefully your work will truly bear that fruit successfully, ending in a vaccine that helps all the producers in the world and farmers. And in order to conclude briefly, I wanted to give infinite thanks to all the different people that made this event possible today. To the different speakers, Dr. Jones, Dr. Vito, Dr. Vizcaino, to all the collaborators that have helped us with all of the setup of the technical aspects, and also those that helped promote this event and made it so successful. I also wanted to thank the people that connected with us from different parts of the world that are interested in issues related to ASF and what's happening in their territory related to the disease. I also wanted to thank the different veterinary schools of medicines from the various universities, and especially Santo Domingo University and the National Pedro Enrique University, Ureña, the UNFU University, and the ISA University that have lent their facilities so that hundreds of students from the veterinary sciences faculty could have access to this transcendental event. Ladies and gentlemen, there's nothing more to say. It is time to be resilient and of continuing to fight for pig farming in our country. Thank you to everyone for your participation. We'll see each other next time. Happy rest of the afternoon to everyone. Thank you so much.